Okay, so it's time for a Nixie relay clock progress update. I've gotten a prototype of my controller board, or the part of the controller board that doesn't have the Arduino or the GPS on it, but has the main switching functions. And I'm actually have the clocks cascaded in it. This is the minutes on top, seconds on the bottom, and I have hours over here, and it's clicking away. So I'm at the system level stage, and so I have a block diagram of what we have. Basically, each counter board, it's now a black box that this displays seconds. It has a reset. It has a clock in, and it has a carry out. There's some clock steering logic. There's some selection logic and a clock source, which I'll talk about each of these things. But basically, I went from the details of how the ring counters worked to then, making that into the hours, minutes, and seconds counters. And now it's abstracted just in this box that has just these three wires coming out. This is reset, clock, and carry, and it's shown here. So to make a clock, there's a clock source. It's either the RTC or the GPS, and that drives the clock. It carries out from the seconds into the clock of the minutes. That carry out then goes to the hours. To set it, there are some switches that then go to the set and test logic, where a CPU, push buttons, or actual switches, I'll describe all this, can be used to change the counters. In that case, each counter module is controlled individually, as when I was testing. So this is the controller board. There's an RTC, there's the divider, and I can select how fast I want the pulse rate to be with this purple wire. That goes into this relay, and this relay basically has the RTC come in, or the GPS can come in, and with this switch I can select the source of my clock. And as a user, there'll be a front panel switch, or the CPU can come in and set that as well. Once that's selected, these relays here are the thing that cascades the counters together, and likewise I can flip this switch and the cascading is broken in this block, and it's driven by these push buttons and or switches, and that is these three buttons right here. And so I can increment the seconds, the minutes, and the hours as appropriate. There's also a reset button for each one of them, so I can reset the minutes, the seconds, and the hours, and then I can set them to whatever I want. When it's in this mode also, and it's not shown here, is there'll be instead of having to press the button multiple times to increment the counter, there'll be a switch which is derived off of the clock source, and here I have it on a fast leg, and I can use that in a test mode to run the counter really fast, just to test it, or just so I don't have to press the button a lot. There's going to be a selector switch on the front panel that selects 1 pulse per second, or one of these faster ones, or there's even I can select a half hertz signal, and it'll count really slow. This is if I want to actually watch what's going on and debug it if the 1 second rate is too small. There's a 1224 switch over here, and then the CPU can read what position that's in. So then it can, when it sets the time, it probably doesn't care actually, but it knows what mode it's in. And then there's 2 buttons here. One of them is used to press it, and the CPU will display the date. And then the other one is a sync button that you can use to tell the CPU to sync and set the time. So when it first turns on, you might want to just run it in manual mode. You press this button and it tells the CPU go and program in the time. And so the details on that, this is how the clock cascading works. I have the nominal pulse per second coming in, and that goes to the seconds clock. Or the CPU can give it a pulse if this relay is set, or the user can press a button, or you can flip a switch which links it to whatever the pulse per second clock happens to be. And there's a green LED for that, so every time I increment it, a green LED flashes, and that's to let me know that it's working, because when the CPU is running things, there won't be a display, so I need to know, what's going on. So that's the seconds clock going to the counter board. Coming from the counter board for the seconds is the carry, and then that lights up yellow when there's a carry, and that comes back and nominally goes through the relay and drives the minutes clock. The minutes carry comes through and drives the hour clock, and then if either the CPU is in set mode or the user sets the set mode, it turns on this relay, which is this relay, which is these relays down here, and that steers the logic from this cascade mode to the setting mode. Additionally, for resets, either the CPU or the user can tickle the reset signal for each of the bits or the seconds, minutes counters. And then the 1224, there's a switch which the user can change, and one of them goes to the 1224 on the hours. The other one, is a signal the CPU can read. And I've documented the pinout of the 3 connectors on the counter boards, and I made the 1224 be not in the same position as the carries, just so that if you miswire it, you don't have the in and the outs fighting each other. And of course I have, again, LED indicators on all these things. It's kind of a light show, but at least you know what's going on. For the clock source, so then the sync and the date, they're pulled low, and you just hit this button and it drives high. And so that's just a signal to the CPU to either sync the clocks or show the date. And then for generating the actual pulse per second, we have the RTC, the real-time clock module, which is this. It goes through, it's behind these ribbon cables. These divide by counters, and I tap off 128 hertz, 64 hertz, 32 hertz, 2 hertz, 1 hertz, and half a hertz, and there'll be a selector switch which selects the rate of the RTC, and then that drives what I call the pulse per second, or the GPS can drive that, and that's selected by, again, this relay over here, and that relay is controlled either by a forced GPS switch, or the CPU can do it as well. Because the CPU, it doesn't know if the GPS unit is in sync, or you might not want to have it be in sync. But if the CPU knows the GPS is validly in sync, then it could switch over and use that as a source. The GPS pulse per second drops, it'll go back to the RTC mode. There's some software in there that I need to work on. I have a really nice selector switch left over from complex sound generator. This one it's nice and clicky, not soft and cheap like the ones I wound up using. This was $10. The ones I used were like 3 for $10. So I like this one, and actually it's a lot bigger than the ones that were used on a complex sound generator. So this will be used to select which tap of that RTC. And normally you would have it on 1 hertz, but again, if you're debugging it or testing it and you want to run it fast, you can run it fast. And so as an example, I can put it on the 128 hertz and just let it fly. And that's the That's the maximum speed. 256 is too fast. It's 64 hertz. 128 is too fast for it. The time on, time off time of the relays, it's 4 to 5 milliseconds, and so you have to do two of those at once. So it's really a 10 millisecond cycle. So the fastest you can theoretically go is probably about 100 hertz. But this cranks along really fast, and again, it's nice and solid. You can see the LEDs in the seconds board, flying around. Everything's working fine. I did have one scare that occasionally I would lose a bit in the 30 on the minutes, and it took me a while to figure it out, and it turns out that there was too much of a voltage drop. Now that I'm running 3 boards, about an amp running through these wires, and there was let me turn this off. And you have to be careful if you turn it off, you get a runt pulse in high speed mode, and so then you lose the bit, and so you can just reset it and then turn it on again, and it's fine. But there was when I run 1 hertz, when I run all 3 counters and 1 amp, there was a 200 millivolt drop through the distribution, and the way I had the power supply, actually it was this one, the smaller one, the way I had it set, it was dropping to 5.5 volts, which meant 5.3 on the board. It really wants 5.6. So I bought this dual supply. It has a beefier heat sink, doesn't get as hot, and I'm going to use that in the real one. And what I actually do is have the logic. I'm either going to have half the boards powered off of each one, or have the logic boards powered off of one, jack it up high enough so that the voltage on the board is sufficient, and then the Arduino in the GPS, I'll have this one set to 5 volts, and that's a voltage that the Arduino will be happy about. And of course I also bought heavier gauge wires to use in distribution, which I'll have on the real boards. I don't have on there right now because I don't want to blow out the holes in the breadboard, because I'm always plugging and unplugging it. On the breadboard, I have extra neat wiring, not the messy jumper stuff I had before, because it's easier to visualize how the layout's going to look on the actual board. And then when you're trying to trace the circuits, having it being a jumble like that, stuff gets caught and broken and disconnected. And so when I was building the hours, I had to refer to my prototype a lot, and it was just kind of hard to see where things were, and you're sort of hesitant to go in there and move wires around to look. And so here, the only things I have that are movable are the 2 selector analogs. So that's where things stand. I'll probably start doing my Adobe Illustrator version of the processor board. It'll be on a board this size, and I'll start building it. I'm going to have the LEDs and these push buttons on the processor board because I'll want to build it and test it and have the buttons, but then the buttons will have a connector which also goes to the ones that are going to be in the front panel, so it'll be in both modes. I can either have it in the chassis or not, and so I want to be able to assemble this and have it sitting here and be able to run it without having to connect it to the chassis. So having these switches here on the controller board will help, and I think that everything's going to go smoothly. I have, and also just again for design ease, these are all the interface signals that go to the Arduino. So I have the resets, the clocks, the 1224, the date, the sync, and then the force GPS, and then the select set versus run mode selections all in here. And so when I build the Arduino prototype, I'll have the board here, and then this will just jump over to the Arduino. And then also actually having the LEDs when I test the Arduino code, I don't have to have the counters hooked up. I can just watch the light show and see that it's actually doing what it should be doing. And then again, making the wires neat. I got good at just sort of knowing how to bend the wires, and then having the nice wire snipper made it just really fast, because I can wire it and then, you know, cut it in place and insert it. So everything's going fine. You know, I haven't designed the front panel yet. I haven't built the controller board. So there's still, you know, a few weeks left on this project. And then I haven't even gotten the Arduino going. I made a little test board where the Arduino toggles lines, and I verified that I can use that to run the counter, but I haven't actually written any code that does anything other than, you know, twiddle bits just for that test. And then the one thing I did like was this, you know, when it rolls over, I can cheat, and actually, if you just notice, that's one thing I have to figure out with the Arduino, since this is a 5, and then the yellow's on, so that the carry is coming in. When I switch this, so every time I switch it on and off, I'm turning the carry on and off, so that's actually clocking that. So I have to be careful if I'm setting a time that's 50. When I turn it, when I turn it back, it's so actually. So when I turn it back, so I'll show you what happens. Normally, I can turn the clock on and off without anything. Actually, I can disable the clock, and I can just switch between set and reset. Nothing happens, but if I'm at a 5, when I turn the clock on and off, when I turn it on to set mode, it increments. Actually, I never really experimented with this, so it's okay. I can set it, and when I put it back into run, it doesn't toggle, but when I put it into set mode again, it increments the counter, and so that's something that I'll also have to make sure that I, you know, do it right when I actually write the code. And I can increment it right up to the brink there. You can turn on the clock and let it run. You can watch it roll over to 2 o'clock. Anyway, so that's just as I expected. It's kind of cool. And I don't have the colons or the AM/PM indicator. I still have to figure out. I have a mounting method, but I'm not sure how I'm going to solder that, because there's no socket. These are nice and robust sockets, and the wiring is protected. The other ones, it's just those leads coming out. So I need to work on that as well. But again, so far so good. Everything's nice and solid. Been handling these a lot. You know, I haven't stacked this on top yet, because I still want to watch what's happening on that. I don't want to have it all in one failure unit in case I drop it. But there's going to be, again, brass standoffs. This is going to go on top, and then the control board on top of that. So I should have, I don't know, maybe some code next week sometime. I don't know. Actually, the board comes first, then the code. Anyway, thanks for watching.